Hi folks, it's Hannah. Today we're going to talk about how atoms can turn into ions. Now we've got three objectives for today. We want to understand the difference between an atom, which is neutral, and an ion, which is charged. We want to understand how atoms can gain or lose electrons to ensure they have a full outermost electron shell, so basically to make sure that valence shell is full. And we want to be able to figure out the charge of an ion. So the first thing I want to talk about is this idea that atoms want to be stable. Now I put want in quotation marks here because atoms don't have thoughts, they don't have minds, they don't have goals or desires, they don't want anything at all. What's actually going on here is that atoms are unstable, and things that are unstable change. So atoms are constantly changing. And they're going to change until they find a stable configuration. Now, once they become stable, they stop changing. And so if you're out in nature, over time, what happens is the unstable things change, the stable things stay. Over time, most things become stable. The way that atoms are going to be able to do this is by gaining or losing electrons. And it's important to note that once you gain or lose electrons, you're going to have a different number of protons and electrons, which means you're not going to be a neutral atom anymore. So let's start by thinking about something like sodium. Sodium is the element with 11 protons. That means a neutral sodium atom has 11 electrons. So we can look at those. We've got 1, 2 in that first electron shell. 3, 4, 5, 6, 7, 8, 9, 10. So a total of 8 in the second shell for 10 total. And then 11 with that 1 in that third outermost electron shell. So I might say that sodium has 1 valence electron in its outermost shell. Currently, a sodium atom is neutral. It has no charge. It has the same number of positives, same number of protons, as it has negatives, same number of electrons. So 11 protons minus 11 electrons gives us a charge of 0. Now, in order to become stable, what sodium wants is to have its outermost shell be full. Now, there's two different ways it could go about this. One option would be to pick up a full 7 additional electrons. That's really hard. 7 electrons is a lot to pick up. The other way it could go about filling its outermost shell is just by losing this electron. If that 1 valence electron goes away, well then suddenly instead of having 3 shells, we only have 2 shells. And that outermost shell, shell 2, which now becomes our valence shell, that shell is full now. So by losing just 1 electron, sodium has a full outermost electron shell, and it becomes much more stable. Now, the other part of this is that something weird happens when you do this, because now I still have 11 protons, but I only have 10 electrons. So I have 11 positive charges, 10 negative charges. That means that this sodium has a net charge of +1. Now, chemists happen to be particularly lazy about the number 1. Usually chemists don't bother to write it. So instead of writing sodium +1, it's okay to just write sodium and then put a little plus up here in the upper right-hand corner. At this point, this sodium has become a charged ion. It no longer is neutral. Now, figuring out the charge of an ion is pretty simple. You take the number of positive charges, which is to say the number of protons, and you subtract from that the number of negative charges, which is to say the number of electrons, and that will give you your charge. So for sodium, we had 11 protons. Once it became an ion, we only had 10 electrons, and that gives us a net charge of +1. And yes, it's very important to say that it's positive. You can't just say 1 there. In chemistry, positives and negatives are equally likely. So really, we always say this is a +1 or this is a -1. This is +2, this is -2. You can't just assume it's positive like you do in math. Now, a neutral atom has the same number of protons and electrons, which means they have a charge of 0. But if you've gained electrons, you've added a negative charge. So if you've gained electrons, you become a negatively charged ion. And there's a name for that. We call those anions, A-N-I-O-N. On the other hand, like with the sodium we were just looking at, if you've lost electrons, you now have more protons, more positive charges, than you have electrons, negative charges. So now you have a positive charge. There's a special name for positively charged ions. We call them cations. The way I remember that is I say cations are positive. So cations are positive, anions are negative. They're both types of ions, which is to say atoms that have gained or lost electrons and now have a charge. So let's think about the sodium again. 11 protons, 11 electrons for the neutral atom, which means its net charge is 0. But for our ion, we have 11 protons and 10 electrons, so we have a net charge of positive 1. Now let's try with chlorine. So here we have chlorine. Chlorine is the element with 17 protons. All chlorines, whether they're atoms or ions, have exactly 17 protons because having 17 protons is what makes it chlorine. Now, if you look at this chlorine and we take a moment to look at its outermost electron shell, you can see it has 1, 2, 3, 4, 5, 6, 7 electrons in its outermost electron shell. So it could either lose all 7 of those or gain 1 electron. So what chlorine is going to do is it's actually going to pick up 1 electron from somewhere else. So 1 electron could come from something like a sodium, could come from somewhere else, is going to come into the chlorine, and then I will have a chlorine anion. Remember, anion is the word we use for a negatively charged ion. Now this has 17 protons, but 18 electrons. So it has 1 more negative charge than it has positive charges, so its charge is -1. Another way I could think of that is by saying 17 protons minus 18 electrons is equal to -1. Now, when we're writing ions, what you typically do is you put the charge in sort of the upper right-hand corner next to the elemental symbol. So sodium has Na as its symbol, and its charge is +1. Chemists tend to be very lazy about the number 1. Chemists don't bother writing it. If you have something with a charge of +1, you can just say Na+. You don't necessarily have to say Na+1. Same thing if you've only got 1 atom, right? In H2O, there's 1 oxygen. We don't bother saying H2O1. Chemists, you can just assume if they don't specify how many of something there is, there's 1 of it. Now for chlorine, once chlorine becomes an anion, we actually change its name. This happens really commonly with anions. Oftentimes you'll sort of chop off the last part of the name of the element and replace it with IDE. So if chlorine becomes an anion, we call it chloride. If fluorine becomes an anion, we call it fluoride. If oxygen becomes an anion, we call it oxide. So we sort of rename the anions. The names for cations stay the same. So a sodium cation is just called sodium. A magnesium cation, just called magnesium. But you can see here how we would write these things out to specify that it's an anion or a cation as opposed to a neutral atom. If there's a charge written next to it, then you're dealing with an ion. So I want to take a moment and have you add some things to your periodic table. So feel free to pause after these instructions, take your time to add these down. And if your handwriting is particularly large, you might want to actually write this on the back of your periodic table. We have some formulas for the number of protons, neutrons, electrons, how to figure out the charge, and how to figure out the number of electron shells. And I think it's a good idea to just have those on your periodic table. So you can see I have written those here on my periodic table. I know that I have pretty small handwriting, so I can fit that here. If your handwriting is bigger, you might want to flip your periodic table over and add those formulas to the back table. You can see them written out here for you. And what I would recommend is video now, write those formulas down, and then hit play once you're ready. All right, ready? Let's move on. So, the thing about ions, once you have an ion, you've become stable in one way, which is to say your outermost electron shell is full now. So for example, sodium, by losing this one electron, becomes more stable. However, you've become unstable in a different way. Because even though you've now got that nice situation where your outermost electron shell is full, now you have a charge. So sodium has a charge of +1, chlorine has a charge of -1. And that charge is a new form of instability. So the cool thing about these is ions basically act like teeny tiny magnets. And with magnets, opposite sides attract. So if sodium is basically a tiny positive magnet, chlorine is acting like a tiny negative side of a magnet. And those two things will be pulled together. When that happens, we call it an ionic bond. Chemical compounds with this. So for example, the ionic bond that is formed between sodium and chlorine, where for every one sodium we have one chlorine, we call it chloride. And the way I would write that is Na for sodium, Cl for chlorine. Of course, things are always more complicated. So it's worth noting that this doesn't just happen to individual atoms. It's not one chlorine and one sodium. You're never going to find a single atom in nature. Instead, this happens to big groups of sodiums and chlorines. If I mix a bunch of sodium and chlorine together, what's going to happen is the sodiums and chlorines are going to arrange themselves in this kind of almost lattice-like shape, where every sodium is surrounded on all sides by chlorines, and every chlorine is surrounded on all sides by sodiums. That, by the way, is the chemical structure of a salt crystal. Sodium chloride is table salt. So you can probably go find some sodium chloride in your house right now. And on that note, I'm going to leave you for today. Good work, everyone. Keep it up.